Sodium hydroxide is corrosive and toxic. Hydrochloric acid is corrosive, toxic, and oxidizes metal rapidly. High temperature mixtures of concentrated acids are used. This method for iodine extraction is extremely inefficient and should only be done for fun. I am in no way responsible for damage to property, persons, or equipment if you decide to do this. First of all, 500 milliliters of iodine-povidone solution was added to a beaker. In a separate flask, 60 grams of sodium hydroxide was added to 150 milliliters of water. Stirring was turned on and additions of sodium hydroxide were made. As you can see, the mixture goes from a very dark brown to a lighter brown. You can still see very dark brown pieces of polymer floating around in the solution, but that's pretty normal. What's actually happening here is the sodium hydroxide is converting the elemental iodine into sodium iodine and sodium iodate salts. The polymer must be pH sensitive, which causes it to precipitate out, which is what you see floating around the top now. The reason this is important is because the povidone is a polymer that is able to hold insoluble elements like iodine and make them soluble by molecular bindings. Anyway, I needed to add another 90 milliliters of sodium hydroxide solution, which was approximately 5 molar. You can see the color get lighter and lighter until it gets clear and the polymer on top is pretty much white, although here mine's a bit more yellow. This color change is very important and it's the indication telling us that we've added enough sodium hydroxide. Anyway, now I have the fun task of filtering this mess. I didn't film the filtration of the polymer itself, but that was an absolute nightmare. I'm using 2 coffee filters for this because the solution is very strongly basic, which can quite easily destroy paper. As you can see, the filtration is running fairly smoothly up until the second addition of liquid. Anyways, I begin the second addition of liquid and the filter paper breaks. I'm not exactly sure what caused this, but I assume the weight of more liquid just kind of killed it. Anyways, I got about 95% of the polymer out, which I was fairly happy with. Now I had to boil the solution down to about 250 milliliters to increase the concentration of the sodium iodide. This entire process took about 4 hours. I didn't film all of it because I was quickly running out of daylight and I should have done this earlier in the day, but oh well. I feel I should mention here that this is really not worth your time in doing. You end up with about 2 grams of iodine per 500 milliliters of povidone solution. Anyway, this is after 4 hours of boiling the solution. You can see it kind of becomes syrupy and there's some polymer on the top. That's pretty normal. I didn't film this, but I filtered the solution one more time and got out the remaining polymer. Our new goal is to boil this down to about 50 milliliters of volume. This took about 4 hours again, and this time lapse shows you how long this takes. I intended on doing the entire 4 hours, but it began to just take too long, so I took photos every 2 hours. If you look carefully, you can see bits of yellowy brown polymer coming out of solution. This happens when the temperature gets too hot and there's not enough water to accommodate the polymer. This isn't a big deal though, and we can just quickly scrape it out with a spatula. Here it is after 2 hours of boiling. You can see there's more and more polymer coming out. Around the 3 hour mark, you can see how much polymer there still was. The closer we get to our target volume, the more and more syrupy and viscous it becomes. Now I let the solution cool completely and additions of hydrochloric acid are made. You can see how exothermic and violent this is, and this was just an absolute nightmare to do. My bench was completely caked in sodium chloride after this, and it was just terrible. Anyway, once it stops reacting, we filter it and get a nice yellow liquid. This is added to 500 milliliters of 3% hydrogen peroxide. What's happening here is the yellow solution contains sodium iodide, which is being oxidized into elemental iodine. It pretty instantly becomes dark red, but still transparent. Eventually it'll become more and more cloudy, as you can see here, and this is the elemental iodine forming. Now all I have to do is make sure everything has reacted completely and wait for the elemental iodine to settle to the bottom. This is actually quite a pretty process. Okay, so here I'm pouring off most of the liquid, which doesn't contain any elemental iodine at all. This is being poured off into a 1000 milliliter beaker just to make it easier for me. Now it's time to filter the elemental iodine. So I wash it with some water and pass it through just a normal coffee filter. This doesn't take long, but I wash it with a little bit of water just to make sure there's no residual acid. So now I take an excess of sodium thiosulfate and add some water to it. I then add that to the 1000 milliliter flask, and you can see the solution become a lot clearer. This is converting any elemental iodine back into sodium iodate and sodium iodine salts. Now it's time to recrystallize the crude iodine we've got. The way I recrystallized it was using evaporation. Even though iodine does sublimate, it also does go into a liquid form. So we can quickly evaporate it by melting it down and getting it to settle on the sides of the glass. The round bottom flask on top was to catch any iodine vapors that could escape. Anyway, now you can start to see the very beautiful purple iodine vapors. These will condense on the sides of the glass like I said. So I took all the recrystallized iodine and added it back to the beaker for another recrystallization. This time I'm only interested in the stuff on the side of the beaker and on the bottom of the round bottom flask. This shot gives you a really good idea of how purple these vapors are and how quickly they accumulate. At this point I'm just boiling off excess moisture and slowly melting down the iodine. It may look like the vapors are becoming almost black, but that's actually the iodine condensing on the sides of the beaker. Because iodine is so insoluble in water, this is the only method we can use for recrystallization. As you can see, more and more of the beaker is becoming dark and recrystallization is pretty much done. I thought it would be interesting to add a little bit of iodine to a watch glass and evaporate it from here. There was still a little bit of water, but you can actually see the purple vapors pretty clearly. As soon as I took the watch glass off the heat, it did actually shatter, but this is okay and I can clean it and use it for boiling chips. Now I have to collect the recrystallized iodine. This is actually quite a pain to do and you don't always get 100% of it. Using a metal spatula is the easiest way and you can just scrape it off the sides. This actually took close to 10 minutes, but this was sped up by a significant amount as you can see. You only want the iodine on the sides of the beaker and on the bottom of the flask. Anything on the bottom can be discarded because it contains impurities. So here's the final yield of iodine. I got 2 grams, which is actually close to 100%. Now I assume this is just because it's a bit wet or contains impurities. There's no way I got 100% yield on this. I had to transport the crystals to a Ziploc bag because they sublimate quite quickly at room temperature, and you can already see it discoloring the bag. Anyway, this is the cleanup. Using an excess of sodium thiosulfate, we're able to turn elemental iodine back into sodium iodine salts. Then the sodium iodine salts can easily be disposed of safely. Anyways, this is the end of the video. Thanks for watching, I hope you enjoyed. If you did, please consider subscribing. If you have a suggestion or a question or anything you want to ask, please leave a comment. I read every single one of them and all of them mean a lot to me.